Hello everyone. So what we have done is, so now we are in the libraries part. We have done NumPy. So do not consider that we have done everything in NumPy. There are a lot of things to learn in NumPy also. And but what I'll do is I'll still keep that playlist open. So once we go to the algebra and we'll see the operations, we'll understand the theory behind the operations. Then we'll see how NumPy lets us perform these operations. But the basics of NumPy are done. You know what ND arrays are, what indexing is, what is slicing, and what are these structured arrays. And we learned a lot about these things. Okay, now we'll come to the data manipulation part by using pandas. Okay, pandas again is a library. It's again a library, so you'll frequently use this because now if you see data, yesterday the main reason to introduce machine learning to you people was to give you the notion that how important data is. Okay, now if you see, the data was somehow stored like this. So I told you data is stored in like tables. Okay, and in which we have these columns. Okay, these are columns, and these columns represent features. They represent features of data. Okay, and each of this row represents one data point. Okay, this is called as data point. Okay, so what is the mathematical representation? I told you mathematically we can represent data like this. So you can write data set is equal xi comma yi if it's a labeled data. Okay, and where I goes from, let's suppose I belongs to 0 to n if we have n number of data points. We can write it like this. Okay, and this is the representation of the data. So here if you see, this can be like this. You can have xi can be a vector. Can be a vector. Taking an example, let's suppose if I take an example of some simple data set. Yesterday we discussed about transaction data. If you have to detect fraud transactions. So in that what you have is, so you will have CC number. CC number will be one of the features. Okay, then you will have transaction amount. Let's call that amount. Amount is one of the features. And then we can have timestamp. What was the time at which this, at what time was this transaction made? So if you make it a table like this, so you have a lot more features. Okay, so these things, if you see, these are called features. These columns, they are features. Okay, and each of the row now, this is a data point. So these data points, let's suppose if CC number is 304, the amount transacted was, let's suppose 120 rupees. At time 1355, something like this. Location this. So each of this row is one data point now. This is one data point. Okay, so this sometimes is called as data matrix. So if you see it's a matrix. If you see this, so this over here is a data matrix for you people. So here if you see this one is a data matrix. If I am pointing in the right direction, this one. Okay, so this is called as data matrix. Why? Because it's a matrix, it's 2D. Why it's called matrix? It's just 2D in shape and it contains data. These are the features. Now if you see, everything has to be performed on this data. So we should have a better way of manipulating, better way of dealing with this data. Okay, so you have NumPy in which you create these arrays, you deal with this, but sometimes you have to load data and there are different formats of data. That's why Panda comes into the picture. Okay, so what Panda is now? Panda is a library and it basically supports various types of data. So first I'll give you a brief thing about data structure. So why is it required even? So why do we study about data structures? And even if you see pandas, they also provide a data structure. If you see array in NumPy, array is a data structure there. So what is the data structure? If you ask me what is it, the simplest way is how do you store data and what operations do you perform on that? So okay, that's what data structure is. So let me give you a physical analogy. So let's suppose if you because you use water for different purposes. If you're, let's suppose, in the washroom and you call somebody, hey, give me some water. So that person will come with a bucket of water because you are in the washroom, probably something happened to the water and he wants to give you the water and he'll come up with a bucket of the water. Let's suppose you're in the kitchen eating food and you'll state the same statement. You'll say, oh, can you give me some water? So probably because you are eating, maybe you are thirsty or something stuck in your throat. So what will happen is the other person who is listening to this, so he or she will bring the water in the glass. Okay, and now if you see that the command was similar, but how it was interpreted depended on the environment. Okay, and it was the need of that environment. So that's the same with the data structure. So when you have to do something, maybe you have the same data. Data is these ones and zeros in computer. So now what you have to do is you have to operate on the data in a certain way. Okay, if you have a certain data structure for that, it makes that operation easy. Okay, so depending on what operation you perform, what operation is to be performed. So different data structures are utilized. Okay, as I gave the example, sometimes we use mug, sometimes we use a bucket, sometimes we use a glass. Okay, the water, the content is the same in that, and depending on what is the use of that water, if you want to drink the water, if you want to use it for bathing, if you want to use it for watering the plants or something like that, you will store that water in different types of structures, maybe in the mug, bucket, or the glass. So similarly, if you see this data, depending on the operation that you want to perform, depending on the work that you want to do on the data, so you have to select this data type. So the famous data types are arrays. So if you see array, what is an array? Okay, array we call, this is an array where we have these run of these elements. Okay, then now there are properties of these arrays. It's indexed, you can do this, you can do that. Okay, but arrays have their limitations. There are a lot of limitations. Then we came up with stack. Okay, I'll just briefly give you a high level view of what data structure are, then why pandas is required. So now if you see stack data structure, it can be made from arrays or from linked lists, let's suppose. Okay, so stack is something like this. So you see it like this. So when you enter an element and gets entered over here, okay, that's called push. And then when you delete the element, you call it pop. Okay, it has a structure. So it has something called as first in, last out. Okay, whatever you put in the first, and this is you can probably also index it. You can have an index stack also, but it can be made. So but this is the way. So when you want to put something in this, so this stack is used, let's suppose, in your browsers. When you want to, let's suppose you are navigating on a website for different pages. So there, whenever you go to a page, it keeps a reference to the older page. Okay, whenever you go back, basically it pops out the current page and gets you to the latest page. That's how, because that's the demand of the data structure. Okay, that's why this stack is used. And again, we have queues. Okay, queue basically means first in, first out. Okay, so we have queues. Okay, and here we have linked lists. So each of these data structure, so it provides you some functionalities. Okay, so depending on the particular task that you want to do, you want to use these data structures so that you perform the operation efficiently. Okay, for how many people can I assume that at least you got a higher level view of what data structure is and why is it needed this way? Can I assume this? It's okay. Now if you see, I told you this is the data. So if you see in machine learning, most of the times I said this is the data. Now it requires us to perform certain operations. Okay, so there has to be an efficient way to perform this. Okay, if you see ND arrays, maybe you can also have ND arrays, but if you see in the data, you must have these headings also. Okay, and then you must have different sort of things. So if you see NumPy, in NumPy you have to otherwise create structured arrays. Okay, that probably will be a little bit slower. Now what Pandas did is, Pandas again, it's a library. Okay, it's a library for handling these data structures. So it is a data structure in itself. It supports different data structures. I'll tell you two of the important data that it supports. Okay, it makes the data manipulation easy. Okay, why do people use it? The first thing is it makes the tabular data handling very easy. Tabular data, because if you see, many other times, I will say more than 60-70% of the times, your data will be tabular in machine learning and probably in deep learning also. Many of the times your data is tabular. Okay, it's in the form of tables which I just showed you. Okay, this pandas, it allows you to work seamlessly with these tables. Okay, like we have tables in SQL, we have tables in Excel. Okay, because most of the data that we store, let's suppose they're stored in relational databases, and that data is tabular. Okay, if the data is tabular, now if we have a certain way, if we have some library which gives us that power so that we can use whatever the existing structure is, existing structure tables, we can use these tables, but we should have some seamless integration. That's what pandas provide. Okay, then you can perform different operations on the data. Okay, so it is, the first thing is tabular like data, and second thing, if you have matrix like data also, if it is just matrix, okay, just a bunch of numbers like we have ND arrays. Okay, and there we can also use this. It makes the operation seamless, and you will see that. Okay, and that's what pandas basically was built for. So whatever existing databases there were, like SQL, we had spreadsheets, and we had data mostly in tables. So we wanted to leverage that power. We somehow wanted to use that and wanted to perform the operations efficiently. That's where the pandas came in. Okay, and there are a lot of things that I can speak about what pandas features are, but that's a waste of time because that's just the motivation thing. So why should you use this? Why should you not use this? So I suppose that most of the times you will use pandas and you will get to know these. Now we'll directly go, what are the data structures in pandas? What are the data structures? Data structures in pandas. That's what we'll first go with. So in pandas, what we have is panda employs two data structures. There are two important data structures. One is called as series and this is called as data frame. Okay, one is called as series and this is called as data frame. So these are the two data structures which pandas have. Okay, so if you see this series is sometimes this is called as container. Okay, let's suppose if it is data frame, so it contains this series element with, so this is called as container sometimes. But what you can for the sake of simplicity, I'll say that there are only two data structures. One is series and one is data frame. So we'll first see what a series is, then probably we'll go to the data frame, and we'll also see how to create these series and how to create this data frames. Okay, now coming to the series part of this, what is a series? Okay, so if you see series, so series is a data structure in which what you basically have, you can just define the elements as you define in the arrays. Okay, so what you can do is in there, so you can define the elements as you were in array. It is just one dimensional. It is one dimensional labeled array. I'll call it labeled array. So this series is one dimensional labeled array, and it can hold any type of data like strings, like integers, floats, and it can store a different type of data, maybe Python objects also. Okay, and but it is what is called as labeled data. It contains label. Okay, for each of the thing it will have a particular label. Okay, the axis label are collectively referred as index. Okay, whatever the labels we have, we'll call them index. Okay, let's suppose we have data like this: 1, 2, 3, 4. This is our data. Or maybe I'll take names. Name is Mahmood. Okay, then we have, let's suppose, Ali. Then we have let's say Abbas and Anwar. So we have these names. Okay, now I said that this series is a labeled data type, labeled array. It is one dimensional. Okay, because you see this is one dimensional. Now if you see in the array we had indexes. Now here this is the index. So but index cannot be a number. You can put index as anything. You can put index as numbers. You can put index as A, B, C, D, something like this. So these labels collectively are called indices or index. Okay. Is everybody understanding what a series is? This is one of the data types that is supported by the pandas. So now what we can do is, so you can have different mechanisms by which you can create this series. Okay, let's go to the coding window and see that. Okay, so let me show you the code. I hope this is visible. I've already made the test1 file. So now what we have to do is, the first thing is we'll import pandas. Okay, so we'll import pandas as PD. So PD is the alias name. So now we have to create a series. Okay, how to create a series? So the first thing how to create a series is you can write the I'll show you the first the generic syntax how you can create the series, and then we'll create it from different data structures. So what you name is, so I'll call this ser is the variable. So the syntax is like this. So we'll write PD dot series. Okay, PD dot series, and then we'll give the elements. So we'll say elements like this. Let's suppose 1, 2, 3, 4, 5. Okay, so if I print this, oops. So if I print this over here, okay, and now I saved it, I'll print it as Python. This is test1.py. So you will see, so this is the series. Now you can see two things over here. Okay, see the importance, two things. Now you see this is these are my original elements. Actually this is my data. So this part over here is my data. Okay, and this part over here, these are my indices. This is my index. Okay, so this is the left hand is on this is the index, and then we have the data. If you just want to clarify, so what type of data this is, you can just print the type of this type of series. So it should show class series, type of series. So this will be of type series. Just running it like this. So you'll see class pandas.core.series.series. Okay, so this is how it is stored. So pandas is the main folder, then we go into core, then we go into series. So from that, this is the series class from which we are creating an object. This is that series. Okay, this is how to create a simple series. Now we'll see how to differently create from the different data structures. As we saw that we can create it from in the NumPy, we saw that we can create NumPy arrays from lists, from dictionaries, from scalar values. That's how we can do it in here also. Okay, the same concept will get repeated, but the syntax will be a bit different. So what you can do is, if you want to, let's suppose, create it from a Python dictionary or something like that. So what you have to do is, you will just write a dictionary. The first thing is, we'll say, let's suppose, if you have an array, a NumPy array. So we'll see it from NumPy array perspective first, because we have been using NumPy array a lot. So import NumPy as NP, and then we'll create a NumPy array. Let's suppose we are saying array of NumPy is equal to NP dot, you know how to use a range. A range will give you a certain range. Let's suppose I'll give me 12 elements. Okay, now what I can do is I can just say If I want to create a series, I'll say series is equal to, I again write the same thing, pandas dot series, and then I'll give as an argument, I'll give this array. Okay, this is my array, I'll give this as an argument. So if I again want to print it, so this I'll just remove ser. Now if I run this, you can see this is what got created, 0 1 2 3 4. But let's suppose I want to change the index. Okay, so there is one more argument which you can set over here, that's index. So if I just see the documentation of this series, you can see this index is there. Okay, so what I can write, I can say index. Okay, index I can write, this again can be, let's suppose we'll say a comma b comma c comma d comma e f g h I. Okay, something like this, but it is giving me some error. Probably we can fix it later, and we'll see what is the error, what does the error it give. And maybe we have to, maybe we can create a list again. So array, I'll say index, I'll create an index array is equal to np dot array. Okay, what I'll do is I'll create it like this, I'll create it separately and give it as an index. So this over here, if I cut it, I'll paste it over here. Okay, ABC, how many elements are there? Now 9, A, B, C, D, E, F, I, G, J, something like this. So I'll say this is my index. So, but the problem now you can see this because I did not put them under quotes. So I should have put them under quotes. That's why it was giving the error. So I'll put it under quotes. Everything should be under quotes. So that I tell the interpreter that this is a string. Okay, now if I now print this, so hopefully it should print it. Okay, there is some value mismatch because we have created 12 elements. So let's create only 10. Okay, so now if you see, I have changed this index. Okay, so is it visible for you people? Can you see that I have changed the index? So the index initially was by default index is from 0 1 2 3 or howsoever it is. Now here I have changed the index. Okay, by using this argument index over here. If you go on the series, you can see this is a class series. It takes this, and then we have this index, and then we can have data type also. We can have name, this is hashable, and you can read about all these parameters over here. Okay, name is hashable default, and then you can also see if it is copy or not. Okay, then it's also showing some examples over here if you want to read the documentation of this. Okay, so this is the first thing we can use NumPy arrays. So whatever we have done is we have NumPy arrays. So sometimes if you just want to read them as data frames, as series. So what you can do is you can just use this series and just pass in this array. And if you want to change the index, you can just change the index. Okay, any questions till here? Any questions? Now the first way you saw, we can directly use these NumPy arrays if there are in the data type, and we can just convert them into series. The second thing is if we have dictionaries. Okay, let's suppose we have dictionaries. And in the dictionary itself, what we can do is we can create a series from that, because you can see that in dictionary we have these key value pairs. We have key and then we have value. Okay, we have pairs of values like this, key value pairs. We have this. So what we can do is we can use this data type. If you see, if I use this key and values, this key can be used as an index. So these keys can be used as an index. Okay, and these values can be used as the normal values what we have. Okay, this is how we can use it. So again, coming to the code, I'll show you that. So if you have a dictionary, let's suppose I have a dictionary where I have names and the age of people. Okay, let's suppose something like that. I'll create dictionary. Let's save this, or maybe comment this out. So I'll come like this. So what I'll do is I'll say I have a dictionary DI. So in this dictionary, so what I'll create is, so I'll have a name corresponding to it. I'll have the age. Let's suppose I'll have a Mahmood. Okay, and then I'll say the age is say 58, something like this. Then I'll create a second element. Second element, let's create something Arshan, and then I'll have age something 78 or something. Then I'll have and the element, call it Asif. Then what I'll do is I'll name it as 56, something like this. So now you know this is a dictionary. If I print it, this is a dictionary. Oops. So this is my dictionary. So if I print it, you can assume that here you can see this as a dictionary. Okay, Mahmood 58. Now what I will want is I want that I can use this as my data frame. But what I'll have is series. So in series I'll have indexes as these names, and then corresponding values will be the age. So the only one thing I have to do is I'll say, let's suppose dictionary to say series ser. Okay, that's equal to, so I'll say pandas pd dot series. Not that difficult, and then I'll pass this dictionary. Okay, that's how you do it. And then if I want to just print it, so I can copy this and print it over here. Okay, now I can save this and run it over here. Now you can see this is Mahmood. Okay, this is 58. Arshan, that is 78. Asif is 56. So this is my index, and this over here is my values. Okay. Now I said you can create the custom indices also. You can now create a custom index. Okay, where you can just define the indices. I don't want, like for dictionary, it is very natural that you can use the keys for these indices. Okay, is it clear? Is it clear? I suppose this should be clear, not that difficult. Okay. Now what you can do is you can also use some other, let's suppose apart from the dictionary, what you can do, you can use scalar values also, which we did. So we can use these scalar values like this. So let me just show a scalar value. This is for the dictionaries. So if I just have a scalar value, but I want to repeat it multiple times. Okay. So let's suppose I'll also comment out this. I'll comment all of this. So if you see, if I have a value, scalar value 5, let's say this is the 5, and for this I want to create a frame, but I want to repeat these values. How I can repeat it? I can just create index. I can say s is equal, let's call it series, se. Series is equal pd.series. Okay, then what I'll do is I'll say s, create s, but now I'll give an index. Okay, index is equal, oops, something is not working. So index is equal, now I'll give custom indices, and if I give multiple custom, it will copy it. So a comma b, then I'll say C, then I'll say D, something like this. Oops. Okay. Now if I print this, so I assume that this 5 should get printed couple of times. How so? I mean the number of times we gave this index. So if I now print this, so you can see this index is ABC, the value is 5. So the one thing we learned is we can have these, let's suppose NumPy arrays, we can create it from them. We can also create it from dictionaries if you saw it, and you can customize the indexes as you want. If you have this index, those labels, you can customize this as you want. Okay, you can create it from NumPy, we can create it from dictionaries, and then we saw we can create it from scalars. We can also create it with different data types. Okay, from with different data types, basically that means, so what I can do is I can just write it like this. So I can say, if right now I was just using the numbers, I can do it like this. I can say 1, 2, these are integers, 3.4, this is a float value, then I can create a string, apple. Okay, then I can maybe write a boolean value true, something like this. Okay, so if I now print this, okay, if I print this one, so this over here, if you see, this is again the index are coming, default index is 0, 1, 2, 3, 4, and then we have 1, 3, these values are there, and okay, and d type is object. If you see over here, d type was int 64. Okay, d type by default is here object. Okay, so then there are different attributes. Okay, different attributes which are, and methods correspond to this series. Now if you see, I told you series is a data structure. Okay, again coming back to the this tab window so that you can see it. So if you see, now you saw that series is a data structure and it has certain ways to store the data. So what I said is there are different attributes which you can call on it. So attributes basically means properties. The series has certain properties and it has some methods also. Methods basically mean what are the functionalities that you can do. There are a lot of methods, a lot of attributes. Okay, but what I'll do is I'll show you some of them and what are the uses of them. So series has different attributes and different methods. So now we'll see them. So attributes basically means, okay, if you have a certain property for that, okay, let's suppose d type. D type is an attribute. Okay, what are their type? So we saw that for some things it's integer 64, for some things it's Python object, and then methods. Methods are the things that you can do on this series. Okay, that we'll see. So now I'll show you some simple attributes first, then we'll go to some more attributes, and but it is not by no means exhaustive methods. So we'll show a few of them, and on the fly, whenever you want to use them, and you can use them on the fly by just reading the documentation. Now you have the series. So what you can do is in the series you can index by labels. Okay, by that what I mean is you can index by this. Let's suppose you have this index. Initially I'll just comment this thing, and we had, let's suppose this, I'll uncomment, these things I'll uncomment. So if you see this one, so if I run this, so this is Mahmood. So how I can even index it? Now you can index it by using these keys. So I can just write Mahmood, give me the value where Mahmood is. Okay, let's suppose like this. Oops. Okay, I'm telling you, okay, give me the element give me the value corresponding to Mahmood. So what it does it will give me 58. Okay, that is one of the attributes. You can use indexed labels. So you have this index, you use these labels and then correspond that. And then there is one more thing. If you, let's suppose you don't remember the index name. So what you can see, you actually know, okay, I want 5th element. Okay, what you can do is you can use what's called as dot iloc. Okay, something like, and you want this index. Let's suppose some second index, something like this. If second is there, probably it is there. So it is this Asif. Asif, we have 57, 56. Okay, so you can use this iloc. I showed you. You can also use to access the indexes. You can directly use the labels. Okay, and then second thing is you can use the values. So if you just print the values, you can write this dot values. This again is an attribute. Okay, so if I print this dot values, so how can you say this is an attribute? Because this does not have these two braces. Otherwise, it becomes a method. Okay, so if this is an attribute, so you can see it over here. Okay, this gives you a list of values. So, okay, 58, 50, and we can see if it's actually a list of values. Print. So we'll say type. Sorry, not print. So we'll say type of this. So whatever it returns. So I assume that this is a list because it looked list to me. Sorry, it is a numpy array. Okay, so you can see that it returns numpy arrays rather, not the lists. Okay, you can just test it because you don't want to memorize. You can see, you saw that like I didn't memorize it because I felt it is probably using the list, but it was using numpy array. You can just confirm it by having this type. So okay, that's one more attribute. So I just said what are the values in there. Okay, and one more natural thing is I can also get indices. If I have to get index, so I can say dict to index. Okay, dot index. So if I now run this, you can see I'll get index. Index is Mahmood, Arshan, and Asif, and these are objects of these are the data type is object. Okay, then what I can see is I can also print d type. Okay, d type. So what are the data type of these things? So now if you see this over here, they are int 64 because it prints the data type of values, not of the indices. Indices are of type object. Okay, these are some of these attributes. Then there are methods. Let's suppose there is a method called describe. Okay, so I can say describe. So we'll get in detail into this because these also apply to data frames. Okay, so it will describe something for me. So if you see count is this, mean is this, we'll get all over these. But I'll just show you some methods. There is a method called a head. There is a method called as tail. Head basically prints the first 5 elements. Okay, if you see, because there are only 3, so it will only print 3. If there were 10 elements, it will only print the first five elements. Okay, let us maybe create that. So what I can do is I'll create np series. So for that, and the first thing is np dot a range. I'll create some 12 elements, and then I'll say index is equal. I'll again create within that. So np dot a range of 12. But now what I'll do is I'll multiply it this with, let's suppose, some 2 numbers, so that indices are different. So if I now print this, printing this to ensure that my data is correct. Okay, now you see the index 0, 2, 4, these are my indices and these are the values. Now what I want to do is I wanted to show you that if I will print dot head, so I said that by default it will print only the first 5 elements. Okay, if you now see this, so it prints the first 5 elements, 0, 1, 2, 3, 4. Okay, by tail means it prints the last 5 elements. Okay, there is another method tail. Okay, why are these methods required? Because sometimes you want to see, I loaded the data, I just wanted to see what is the format of the data, how does my data look like. That's why sometimes you see tail and sometimes you see head. Even these take arguments. Let's suppose within the tail now you don't want to only see 5 elements. You want, let us suppose, see 7 elements, last 7. You can just write 7 over here. So you can read the documentation. If you go to tail, you can see it takes parameters n. Okay, now if I just run it again, so you can see it gives me last 7 elements. If I just wrote head over here, so it will give me the first 7 elements. Okay, these are some of the methods. And we have sort values, we have sort index. There are a lot of methods. I just showed you some of these. And then series also lets us perform operations. Okay, you can perform addition, subtraction, you can perform Boolean indexing, you can handle missing values, you can apply functions, reindexing, you can do a lot of things. Okay, now I will again summarize. So what basically we have studied about series, we learned how to create the series. Okay, so we read about series. So series is nothing, just consider it like an ND array, but it is labeled. Okay, and what it has, we saw some attributes, the series. Attributes. So in these attributes, we saw if you just want values. So values is an attribute. So we can have an attribute called d type. Okay, we again saw some attributes. I think some of that, what did we saw? We saw maybe index. Index is also an attribute. Okay, and there are a lot more attributes that you can see in the documentation. Then we saw there are methods possible. You can perform different methods. By methods, I mean you can have this, and the methods, let's suppose the first method which I showed you is the method of, what's the first method I showed you? Head or tail, and describe probably. I showed you first describe. So I did not explain describe what describe is. Maybe we'll see that in the coming couple of minutes. So describe basically it describes what is called as stats. Okay, it describes different statistics of the data set. And then I showed you head, I showed you tail. Okay, so these are all methods that you can do, and there are again a lot more methods. And then what I can say is there are different operations that you can do on these things. So there are operations possible. There are different operations and this is where once we have the real data set, we'll perform operations. Okay, then we can index it. You can handle missing values. You can perform operations. Okay, I'll just write these things now. You can perform different operations, and then you can index the data set. Okay, by using different types of indexing. I showed you maybe a few, and then what you can do is you can also handle missing values. Okay, yesterday we saw what missing values means in the data. Sometimes there is an equipment error for a data point, for a certain feature you did not have a value, so you have to handle those missing values. Okay, you can apply functions onto these. Okay, you can apply functions on the series. Okay, and then what you can do, you can also reindex it, and a lot of other things are possible on these. So now you see what a data structure is. There is a structure where you keep the data, and that allows you certain methods, that allows you to perform this, and that allows you to perform these operations and the things that I showed you. This is one data type that I just briefly introduced. So is everybody on the same page? Is it clear for everyone? Okay, nice. So we are done with the first data type that the pandas provide. The second data type that pandas provide is called as data frame. Okay, so this is the second data type that pandas provide. So what is a data frame now? So data frame is now two-dimensional labeled data. So in the first thing we saw, we have this one-dimensional labeled array. So here what we'll call it two-dimensional 2D labeled data structure. Labeled data structure. So here now you'll see it has 2D, okay, and it has these columns, and each column might have different data type. Okay, so you can think it like a spreadsheet or maybe Excel. So if you have seen Excel, so we have these spreadsheets in which we have these, we call them cells. We have these rows and columns. Okay, so now what we can do is in each of these, this is a feature, and feature may have different data types. So in the transaction data, as we said, so there can be strings, there can be numbers like integers, there can be float values. Amount is a float value. Let's suppose somebody's name is a string. So these can be of different data types. As it is 2D now, because we have axis 0 and axis 1. We have two axes. We have this axis 0 and axis 1. This is the 2D data. Okay, now this data frame actually is a two-dimensional labeled data structure with columns that they have potentially different type. They can be of same type also, but they can be of different types also. So as I said, you can think it like a spreadsheet in Excel. Okay, and now what it basically has in this, so each of this thing can be treated as a series. So each of this can be treated as a series. Each of the data point. This looks like a data matrix now. That's why I showed you the first thing, the data matrix. This looks like a data matrix now. So each row can be thought of a series, and each column can be now thought of a feature in that. And this is the data point, and these are my features. And features have different types of data. Now what we can do is data frame, it accepts many inputs. It accepts, let's suppose, 1D arrays, it accepts ND arrays, it accepts 2D numpy arrays. You can have a structure of records, you can have a series, maybe and the data frame within the data frame, and there are a lot of things that you can do onto this. Okay, so now we'll see how to create this data frame. Okay, that's our point now. So first we saw what series is, then we saw how to create it, then we saw what are attributes, what are methods, what operations possible. Okay, same with the data frame. And in the subsequent lectures, we'll be working with series and data frames. So in this today's lecture, I want to introduce you to these data types where we have this series and we have the data frame. Then we'll see how to handle the different data and what operations to perform. Okay, so now we'll see how to create this data frame. Okay, how to create this data frame. The first thing I can do is, so I can create it from a dictionary again. So if I show you how that dictionary is, let me again go to the coding window to show you that. Now I'll create a new file, call that test2.py. I want you people to type this code also. When you are at home watching these lectures again, please do type them, because as I said, it's very easy to fool yourself that I understood the concept. It's very easy. So because when I'm coding, so many of the things I am writing these things and many things are going on in my head. So, and you are assuming that I understood it, but when you write it yourself, and then you get many doubts. Why am I putting this equal to? Why am I putting this comma? And you basically focus on small details, and those small details make the concepts clearer. Or you can get doubt, and then you have to solve that doubt. And once the doubt is solved, you get the better understanding of the concept. That's why I'm saying you should type these things. Okay, when you see the lecture, try to type. Am I getting the same output? And then once you are in the assignments, then there you should do the things without help. What I can do is I can first see, I can have these dictionaries. Let's suppose I can create it from these data frames from the dictionaries. I can create these data frames from the series. Okay, let me show one of the ways where I can create it. So what I can do is I can have a sort of dictionary where I'll put the name and I'll have multiple keys corresponding to it. Let's suppose something like this. I'll say import pandas as PD. Okay, this is my pandas. This is the import statement. It imports pandas, and I'm using alias PD. Now what I'll do is I'll say df. Df is data frame. So now what I'll do is PD dot data frame. Okay, so data frame, and after that what I'll do is I'll basically write a dictionary like thing. So within that you can see that now I'll write a dictionary like thing. So the first element could be, let's suppose, name. I'll say names of the people. So I'll make, this is the column. So I'm creating names. The one column is names column. Okay, and the columns can be age column. Then we can have sex column. We can have nationality and something like this. Let's suppose names. I'm creating names, and with this what I can do is I can create a list of keys now. So corresponding to this I can create list of keys. Okay, so the first name is, say, Mahmood. I'm using Mahmood's name left, right, center, everywhere. So now I can use Ijaz. And then the third name can be, let's suppose, Anwar. Okay, and now I have, let's suppose, some fourth name. Some fourth name can be Arshan. Okay, this is one of the columns. If you see this sort of thing, this will be one column in my data frame. And now what I'll do is I'll create a second column. If you now see, this is something I'm creating into the dictionary. Okay, now I'll say something age. Okay, age again. Okay, and is 2. These are my indices now. So these are the column names. At the top I'll write column name. So I'll say what is the age. So age I'll again write 55, 64, something like this, 45. I have 4 names. So I wrote 4 ages. Then I'll again say, let's suppose I'll write nationality. Nationality. Okay, don't take any offense if I write some other country. So I'll make up countries. Somebody is from country ABC, and somebody is from this country. Okay, and somebody is from this. These are my countries. Okay, let's say these are the 4 countries that I have. I made up the names, and let's suppose I'll also write the grades. Let's suppose this spreadsheet I'm making for the course. I'm writing the grade. Okay, what is the grade that you got? Okay, so how I'll write it? I'll say the first person got grade A grade, and then I'll say again A plus, something like this, and then I'll say B and B plus, B comma B plus. Okay, this is how I created this data frame. Okay, now if you see this, what I can do is I can I just need to put commas over here because these are different values. So I need to put commas. That's what I forgot. Okay, still there is an error somewhere, so I need to put comma over here also. Yes, that's why I'm saying you should type these things on your own. Why? Because you'll otherwise miss these minute details. So if I say print this data frame, so now you will see it will look like a data frame. Okay, so I'll say Python test.2. So oops, what is happening? Python test2.py. So now if you see, this looks like a data frame. If you see it over here, so names are this, age is this, nationality is this, grade is this, and we have this indices also. So how many of you are able to understand this? So we just use some sort of dictionary. Okay, and within that dictionary we said we have a key value, and then we have this keys, and we have this corresponding multiple values. So this over here, they are the columns. Yes, any questions on this?
By default here series it is going to print, right?
By default it's going to print what? Again, come again, sorry.
Series, index series.
This series by default, yes. Otherwise you can put it false. So if you want have it, so you can set index as false. Okay, by data frame, if you want to do this, maybe there is a parameter index, so you can set it false, index false. Okay, good question. So if I just print it now, oops, index contains this, so you'll have to see this. It contains a copy like this, otherwise there is drop index or something, or there are a lot of methods, and I myself don't remember. This is a proof that I don't remember these things. So if I need it, I'll just read the documentation. But there is that where you can drop this index. Okay, I'll again go back because I don't want to debug the code, because debugging wastes more time. Okay, and if you people have the experience with debugging, so you know coding takes less time, debugging takes more time. That's why when I get some error, I just I say that you should go to documentation. Okay, but by default this index is there. Okay, 0 1 2 3, this is the index is there. Okay, so now what I'm saying is, if you see this looks like an Excel sheet. See it like here. So it looks like an Excel sheet. Now again the same thing is, you can print, let's suppose head, and you want to print the first two elements. Okay, now you just want to get that. Okay, you got the two elements, and now you also got, okay, this is the columns, this is this. Okay, and you can say dot index also. There are a lot of methods. Dot index. Okay, now you got, maybe this is not an attribute, this will be a method. So again, if it is not there, you can just search for it. Maybe it's not there. Okay, now you can say dot columns. Columns, I believe is an attribute. So now you see these columns are names, age, nationality, grade. Please do not remember anything. If you keep on remembering, you will be expert probably at one thing. Otherwise, because you have to use libraries everywhere. So if you try to remember, okay, what is the syntax, what are these things, so you will rather waste time than learning. So here you should know these things exist. What should you do afterwards is just Google search. I want to print index. How to print index in this data frame? How to drop index? So it will tell you how to drop. But you should know there is something called a data frame. There is something called a series. You should know these conceptual details, and you should not remember the things. Otherwise, you'll waste your lot of time in remembering the things. And you know, after a while, you'll again forget it. Okay, you still forget it. And I still, you see, I almost use the data frames daily, but still I forget it. Okay, and I know this. I can index it. Like this is called as, there is I usually index it like this. If I want, let's suppose what's the third column, I say df dot columns dot third. So it will print me this third column, something like this. Okay, and even if I use it daily, still I forget the syntax. Why? Because I do not focus on syntax. That's what I am telling you people, not to focus on syntax. Rather, there are documentation. That's why people write documentations, because it is humanly impossible to remember everything that there is. That's why we keep it safe somewhere. And even if you see the developers, they themselves don't know most of these things, because they have written something and they again go back to documentation. That's why we maintain the code that way, because if we forget something, if we implement it in a certain way, we should go back and see how we maintained it. Okay, I hope you got the point. Okay, now you see this is the first way where you can create this data frame. So how to confirm this? Oh, this is a different data structure, so just print the type and then you can say df. Oops. Now if I print this, you can see this is class again defined in pandas core. Then we had series. When we are printing series dot series. Here we have frame dot data frame. Okay, is it clear for everyone? Is it clear? That's the first way. How we can do is, and the way is we can create it from series. As I said, each of the row can be thought as a series. Each of the row can be thought like a series. Okay, let's create this data frame again. Okay, this is, I'll comment this. So I'll create a data frame once more. So this is df. Okay, that's equal to, again what I'll do is I'll again call the same thing. I'll say, let's suppose d, maybe I'll make a separate d, and then I'll call it this df pd dot data frame. So how can I create a d? So I'll create a series of these. I'll create multiple series, but these series will be like dictionaries. Okay, again what I did is, so I'll create like this d. So what I'll do is I'll print an index. So that is, say index is 1, maybe column name, not just index, it's column name 1. Then what I can do is I can create a series over here, pd dot series. Okay, so within the series I can have the values, or I can have the values like this. I can say 1, 2, 3, something like this. Okay, so but one thing should be clear, I should make it within this, otherwise it will give me an error. Again, reiterating it, it's very easy to fool yourself when you are seeing somebody code. So that's the better way is to code yourself, so that you don't even miss these minute details like the brackets and the commas. You don't miss them. Okay, then I can also put the index. Let's suppose if I want to put index like this, comma index. Expect errors, but that's all right. I want to convey the concepts, not the errors. If I'm getting an error, I won't debug the code probably, but once you are watching the lecture again, you should debug it yourself. Okay, let's suppose we'll create this 2. Okay, again I'll create this as a pd.series, because I said each row is like a series now. Okay, now what I'll do is I'll now create more elements. Let's suppose I'll create 1, 2, 3, 4, something like this. Okay, comma index. Okay, again I'll say, I'll print, let's suppose ABCD, A comma B, oops, why is it not giving that, B, oh no, I don't see it again, comma C, there is some issue, but we'll fix it rather, don't worry. So D, this issue has to be fixed, so we'll put comma over here. Now is there a problem? Yes, there is one this inverted quote missing, and here also we have this missing. Okay, is there? Yeah, now it's right. So what we can do is, from this we can create a data frame now. So what I can write is, I can write df is equal to pd dot data frame. Okay, then I'll give this d. Okay, now if I print this, so this df, if I print it over here, so you can see it like this. Okay, so now one more important thing, why I created this, I was expecting an error, or maybe it worked. So if I expect an error, I would have read that error, but here if you see this, what we can get is, we had these indices, we had this indices A, B, C. There were only 3 indices, and there were 4 indices. So if you see this, so we created a series like this. We have this 1, 2, 3, 4. What basically it did is, so for 1 it did 1, 2, and 3, and then it gave NaN. Okay, the 4th element doesn't. That's what this is, the missing value. So this I'll call a missing value. Okay, because let's suppose we were collecting the data points. So usually we assume that the points, all the features will be given values. But now the point is, one point was not given the value. Okay, but we had this, D had no value. So we put this NaN. NaN is basically means not a number. We don't have a number there. But if you see the index was given A, B, C, and D over here. And then it automatically adjusts internally. That's the powerful thing about that. It adjusts internally. Okay, let me explain one more thing. So if I, let's suppose, say for D feature we have the value, for the D we have the value, but let's suppose for the data point D we have the value, and for the other thing we keep NaN, let's say something like this. So you can see now we got for values this index C, okay, for this data point, C data point. So if we have this NaN number over here, because for C I did not give the index. Is it clear? Now you see this, consider each the thing a data point. Now data point should be homogeneous. By homogeneous I mean that whenever you collect features, let's suppose you collected features about one transaction, the same feature should be for the other transactions, but there can be missing values. Okay, so missing values can be, let's suppose you don't sometimes you don't have timestamp, so you can put these NaN values, and after that we'll have to deal with these NaN values. These not a number value, missing values we call them. We'll have to deal with them. Okay, so the second thing we saw is each row can be thought of like a series, so we created that from the series. Is it clear? Is it clear? I'll have to see it. Yes. Okay, now let's suppose you want to reindex this. Okay, I was telling you how to reindex the things. So okay, I wrote that function index. So what you can do is, you can just say pd or data frame comma. You can put your own index. Okay, index. Let's suppose you want to put the own indices. Let's say some D, maybe some B, comma, some X, comma W, something like this. Okay. Now if I print this, now you see this. This index, let's suppose B is over here. So okay, what it does is it will only take corresponding B values, but X values are not there. It is showing NaN values, NaN. Okay, but let's suppose if the other value is there. Okay, let's suppose you collected data. Think it as a real world scenario. Okay, that's why these things do support these features. So what am I telling you is, let's suppose think about the real world. You are collecting data. Okay, let me go to this tab window. So you are in the real world. You are collecting data, and let's suppose you are a botanist. Okay, think it like this. You are a botanist and you want to collect data about the flowers. Okay, let's suppose you have these 4 features: petal length, petal width, and sepal length, sepal width, and let's suppose maybe height of the flower, something like this, total height. These are the 5 features that you are collecting. Okay, and you took one flower. Okay, and you collected some data. You collected some values 2, 4, 6, 8, and let's suppose 10, something like this. For second flower, this is flower number 1. Flower number 2. So what you did is, for flower number 2, you said petal length I cannot measure precisely. Somehow you did not have, you have missing value. But for these things you have values. You have 4, 8, 9, 12, something like this. And for the third plant you have these 3 as missing values. Okay, but what you did is you had these values 12 and 8, something like this. Now what I'm saying is, so I'll create these as series. Let's suppose I'll create these as series. These things will be created as series. Okay, now sometimes what I want is, now once I created them as series, then I'll give the index from my side. I'll say my index are petal length, petal width, sepal length, sepal width, and the height. These are my 5 features, and maybe some of them, for some of them we didn't have not collected data, but some of them we have collected data. That's why I showed you this example over here. So if you see this, so in here the data was like this. So we had features A, features, let's suppose for B, for these are data points, A, B, and C. For these things we had this. So for others, let's suppose we did not have. We have, but in our case we had more of this. So what I wanted to do is I wanted to show you. Let's suppose if we have this data point. Let's say this was now say C, maybe D. So D, because for D we have these values. We have these data points over here. So now if you see this, so for this is the B, so B has 2 and 2.0. So with this B data point has these values. So for this value, for this X, so let's suppose X is the data point. So for this we have no value. And for this D we have the value 3.0 and 4.0. Okay, that's how if you collect. Sometimes you say this is my data point and I collected it, it does not have some values, and sometimes I don't have any other data point which has these features, and you can use it for filtration the data also. Okay, that you will get to know slowly once we work on the real data. So this is again one the type how you can create. So again take away point is that you can create each thing by this series, and then you can sort of reindex them, basically filter them based on the data points. Consider these as data points A, B, C, D, and you can filter them. I said let's suppose X is a data point, but X was not there, so it is showing not a number. Okay, is it clear? I suppose this is clear. I gave you an example to understand it. I suppose this is clear now. Okay, now what I'll do is, so we'll also have these, we can rename the columns. Okay, let's suppose here we had these indexes, we can have columns also. Let's suppose we can say comma columns is also one of these arguments which is data frame take. So argument, if I take columns, so what I can say is if I have these columns, let's print it without columns first. So if I print it without columns, so this is how it looks. Okay, now this is my 1 and this is my 2. These are my column names. If I want to change these column names, so as we have it here 1 and 2, so we want to change them. Let's suppose we want to change them like this. So I'll say columns, I'll take a list, I'll say sepal length, sepal maybe, and maybe petal, something like this, comma petal. Okay, now if I run it, I suppose this should get changed. But many times you won't be doing much of this, but you should know that these things do exist there. Okay, now if you see this is sepal and this is petal, but there are no values for these sepals, no values for these petals. So I'm assuming that's why it is not taking these values. Okay, so but if I say I just want to take column where we have 1 and we have petal, so it's basically not renaming it, it is only taking the column, it is filtering the data. Again, if you see this column, this indexing, these are all filtering methods. Okay, why am I saying it? You won't use it many of the times because you will have your data set given to you, and during the preparation probably you will have to filter. Okay, there's a difference by selection and filtering. So if you see both of these, what we did so far, this index and this column, they were used for the filtering. Okay, coming back again on this data, on this example. So if you have this index, so it filters these points, it filters data points. It filters the data points. So coming to that columns, it filters the columns. And sometimes you want only certain columns. Sometimes you see if there's an additional column or something. So you want to select only certain columns. So what you can do is you can just write the function. So from that D, so you will have this index, and index basically corresponds to data points. And then we have columns. These columns, they correspond to features. This is what you should remember. So these are data points. And you should have this picture in the head. And for the transactions, let's suppose this is transaction 1, transaction 2, transaction 3, and these will be the corresponding features. But sometimes you only want to select the timestamp. You want to select timestamp for all the data points, and sometimes you can select both. Okay, so that's why I said these are basically for the selection or for filtering, Okay, this thing is either for selection or for the filtering. So let's suppose this is my data and I want to just select, let's suppose, point B and point A. So what I can do is I can do it like this. So I can say point A, comma point B, give me only 2 data points. And for these, I just need the first column. I'll say 1 and don't give me other columns. And I want to make it a data frame. So let's suppose if I run this. So now you can see this, I got the 2 data points, point A and point B. And for that, I just got the 1 column. Okay, so these are 2 arguments, index and columns. They can be thought as like selecting or filtering. I want to filter or I want to select. Is it clear for everybody? Because when the times you will be doing it in the real world, you will be doing this. When you have data set, you just want to select few data points. You just want to select few columns of that. So you can use this index and columns. Okay. And now what you can do is I was telling you that this function should be the df.index. Okay, df.index. I don't know why that time we got an error, but it should be there. So if I now print it, yeah, now it is showing the index. We have index A and B. Okay, So index over here is because I have redefined this df over here. So index is a and b. If I print these columns, okay, so columns, we see these are the columns. Okay, we have the column 1 only here over here. So if we just created the whole d without this index and without this, so I can just erase it maybe. And then if I print columns now, the columns should be this, these 4 columns rather. So I'll have these columns will be this one and these 2 columns. So if I print indices will be these a, b, c, d. So if I have this index, okay, so this is index a, b, c, d. Okay, so if I, let's suppose again, if I print the type of this, so what's the type of this? So we initially saw it was a numpy array. So here you can see this is now pandas core.indices. So it has created again a structure within it which is called as index. Okay, so if I print for the columns also, again there is no need to remember these things. Why? Because you can check it on the fly. Okay, if you see this columns is again this itself is an indice. Okay, so you can have these attributes. Again, we saw the same thing for the series. We are seeing same thing for this. So here the first thing we saw is, let me just close this. The first thing that we saw, am I audible? I feel something is not correct.
Yes, sir, you are.
Okay, so we studied about data frame. So in that data frame, I said think it as like a 2D array, okay, in which we had these indices and we had the corresponding features, column names also. Okay, so in that we saw different methods. So we again saw attributes. So attributes are also there. So attributes were like we had D types attributes. We can have different type attributes, and then we saw different type of methods also. Like we saw head, tail also they apply over here. So in here you saw index is attribute. We saw attribute as columns is an attribute. Okay, indices give you the index basically data points. Columns give you different columns. So in the methods you can apply head onto that. You can apply tail onto that, and there are a lot more methods. Okay, so this is about the, this data frames, and there are way more methods to create these data frames. So you can again have list of lists. List of lists basically means 2D. So I'll also show you that. Maybe just an example, so as to clarify, you can also use lists. But most of the times you won't create it by hand. So let me tell you, you won't create a data by hand. Otherwise, if you have to create all the things by hand, so it becomes difficult. So what you basically will do is, you most of the things will read it probably from CSV file or from some TXT file or some other file. Most of the time that you'll do it. But you should know that there are methods that where I can by which I can create it myself. But you should know this. But you should not remember all the methods. That's why I'm saying I'm against rote memory and memorization. Okay, but you should have the conceptual clarity that there is a concept which exists there. Okay, coming back. So now if I want to create it from list of lists. So we saw first we can create from the dictionaries like this, and second thing is we can create it from series, and the third thing we saw is we can create it from list of lists. So let's suppose I have a list called data. Okay, this is a list of lists. Okay, so that means I'll have a 2D matrix sort of thing. So in the first list, let's call it like this. So I have names, age, and maybe sex. So I'll say Mahmood. So Mahmood is being heavily used. So I'm saying age is an integer, say 50, and then I say male. Okay, so and then I'll create a second element. So if you see, oops. So here this bracket should be here. Okay, that's why I'm again telling you to type the code yourself. Okay, otherwise you won't figure out these mistakes. So then we'll have maybe Saida, something like this, and maybe let's suppose her age is 45, and now obviously she's a female. That's why I created a made-up name. And then one more thing, we'll create, let's suppose Anwar, age is maybe 54 something, and then we'll say male. Okay, now if you see, this is a list of lists. So usually we create it like this for the better clarity. So if you see it over here, so this should be indented properly so that for people it's also visible. This all is just for the syntactic sugar so that it looks proper. Okay, and now what will we do is, so we'll just convert this data into this. So you'll just print data over here. And now what is this df? So we'll again just print the data first, this df. Okay, now if you see, it gave by default these indices and the column names. Now it got the values by default. Okay, so what I should do is, if I want to reindex it, okay, I can maybe write indexes. So I can say maybe index are good. So I can start from 0, 1, 2, 3. 0, comma 1, comma, no, not from 0, 1, comma 2, comma 3. Okay, I want it to start from 1. So what I can do is I can say comma index is equal index. Okay, so let me first check it if it works. You should test everything. Yes, it works. Then I can change columns. So I can say columns is equal to, so we have name, this is the name column. Then we have the age column. And then we have the gender column or sex. So here, if I, oops, something is happening. Yes, now if I print it, no, one more thing I have to add this feature of column is equal to columns. Okay, so now if I just run it, so you can see I got the column names, name, age, sex, and this 1, 2, and 3. So if I just increase the column names, so it should give me an error. So, or it should give me not number values. It depends on the implementation, how they have implemented it. So if I added one more column, it gave me error. Okay, so one more implementation could have been, so they could have added just NaN, but they thought if it's for everything is for NaN, so there is no point of adding one more column with NaN values, because anyway there is no value in that. It's best to reduce. It's best to remove that. Okay, maybe if I just have this data point, I'll create one more data point. Again, two ways of implementing it: either create all NaN values or remove the data point itself. By removal, I mean that this error should be there. Okay, so it supports this index should be equal to the index and columns. They should have the equal number of values. If they are not equal number of values, it depends on if your indexes and you have these 3 points over here. You have these 3 values, so you should have 3 indices also. And if you have these 3 columns, so you should have similarly 3 columns. Let's suppose if I add one more thing over here. Okay, just for the testing purpose. If I add 50 over here. Okay, if I now print it. Okay, now again you can see the error. So we're expecting 4 columns. Now we have 4 columns. We'll add one more column. Oops. So actually this is a comma over here. So this was giving the error. Now I'll put one more column over here. Maybe some ABC, something like this. Okay, other 2 will get not a number value. Here if you see now, other 2 will get not a number value. So for the first data point, we had 4 features. For other 2, we had just 3 features. What it did is, it automatically added not a number features for these not number missing values, basically for other data points. Okay, and for these indices, I said 1, 2, 3, and I can add one more data point. Let's suppose I'll say hello is somebody's name. So for all data types, what we'll get is, so here I should add one more index 4. If I don't add, I'll get an error. So now if I see it, now you can see it got 1, 2, 3, 4 hello, and for all it got values NaN because these are their numbers, and for the other where we have these strings or object, it got value none. Okay, and this NaN and none, they are missing values. Okay, this over here is a missing value. Is it clear how can we create it from list of list? And I showed you different things that you can do within the list of list. Is it clear? Okay, for how many of you is it clear? Okay. Now we'll learn, maybe there are a couple of more methods I would like to tell you these things, and after that maybe we'll take the other parts of manipulation in the next session. So this is one more way of creating it from list of list. Then we can again create an empty data frame. We can create empty data frame, and what we can do is we can add the values. Okay, how to do that? Okay, let's, maybe now this is becoming a lot bigger, so we should save it and open a new file. Code test3.py. Now what I'll do is I'll first import pandas as PD, and then what I'll do is I'll create an empty data, that's called as empty data frame. Empty data frame. Okay, so how to create it? Simple. Let's suppose df is equal PD dot data frame. Nothing in this. Now this is empty. Now what we can do is, now we can add the values in there. Okay, so we can add values like this, df of. So what we'll do is we'll say we'll insert a column first. We'll say name. Okay, at the name we'll add 3 names. Let's suppose we'll say the 3 names are something like this. So I'll say Bahmood. I'll say Anwar. Okay, then I'll say maybe Asif. Okay, so these are 3 names. So now if I print this data type, if I print this df, so initially I created nothing. So if I print it print, so df initially was empty. So that I can confirm by just doing this. So I can do this, it showed nothing. Okay, so but when I inserted these things, so if I insert the values, okay, so now if I say Python, oops, why is it again happening? I don't know. So it's better to write Python test3.py. So now if you see, this date name is names are this is the column of names. Okay, so initially I was showing you if I don't have this, this should be an empty data frame. Okay, now it's empty. There is no column, no index, nothing. Okay, so now but it gives you that you can insert columns. This is the column name, and this is the Mahmood, Anwar, and Asif. So you can also index it. So you can say comma index is equal to something. Okay, this is again inserting. So if I want to insert age, so what I can do is I can call age over here. Then I can give the age. Okay, so I can say age is 15, comma 18, comma some 45, something like this. So now if I print it again, so I should get one more column, that is age. Okay, I can create index also. Oops. So I can create index also. So how to create index? I just have to say index, that's equal to, so I'll say I have two data points, 1 and 2. So then I'll say comma index is equal to index. Okay, if I save it, I hope that I should get indices also. What is happening? Python test3.py. Why is it happening? It happened. I'm adding in the print. You should tell me to add in here. Index is index this. Okay, I'm adding in the print. Initially, I was also doing in the print. That's why I do this silly mistake sometimes. Okay, this index we can add it after data frame. We can recreate the data frame rather. Okay, or let's not do it here. Or we can add column names also. But you got the idea. So you saw the subtle mistake I was doing. This is a nonsensical mistake. I was just printing comma here. I was saying print index is equal to index. Rather, I should have done it in the data frame. Okay, that's why I'm saying when you code, you sometimes don't realize where are you putting things. Okay, and that's why you should code yourself, and you get to know, okay, this is the error. Where am I making the error? Okay, and now I showed you how to also initially create an empty data frame, and then you can insert the data into that. Is it clear? Okay, I'll show you one more way. One more way is to basically create it from NumPy arrays, because NumPy arrays we are already familiar with that. So what we can do is we can create a NumPy array, and then we can just maybe rename the columns index. Let's suppose I'll create that. So I'll have to just I'll comment this out first. So I'll comment it out. I'll say import NumPy as NP. And then what I'll do is I'll maybe create some random number. So data is equal, I'll create random numbers. I'll say np.random. np.random. Oops. A random dot, I'll say rand. And then I'll give some size because it requires size. I'll say, let's suppose create a matrix of 3 cross 4. So 3, 4 basically means it has 3 rows, 3 data points, and 4 features. Okay. Now what I can do is, if I do it like this, data frame is equal to pd.dataframe. Okay, and then I'll give this data as an input. So data is equal to data. So what will happen is, so if I now run it, it should work. Yeah. What is happening? So I should write Python. Then I should write test3.py. Test3.py. Okay, but I have to print it. Yes, printing is missing over here. So I should print it. Print df. Okay, now going back over here. You can see this, it printed these because it generated random numbers. Okay, maybe I should generate random integer, but I should generate in a certain range for that I give the size. So I think this makes the point clear. So now what I can do is, if I want to index them, I can create indices. Index is equal, let's suppose, because there are 3 data points, 1, 2, 3. Then if I have to create columns, I can create columns. Columns maybe, let's suppose these are feature names are A. Then we have second feature name, that's B. Then we have third feature name, let's suppose that is C. Okay, now if I want to do this, so what I can do is I can just call it over here. Data is equal to data, index is equal to index, index is equal to index. Okay, then comma columns is equal to columns, columns is equal to columns. So I have told you about these named arguments. So these are these named arguments, keyword which we call as. So now if you oops, again something is wrong. Because 3, 4, 3 should be indices, and we should have 4 of these. Yes, so we have D. Okay, now if you run this, it should hopefully run. Now usually we have this A, B, C, D. If I just want one of that column, so what I can do is I can just print that column probably. I can say dot of A, maybe it like this. I can say dot A if I just want A for all the features. Okay, that's what it shows, A for all these features. I think somebody has a question. Yes, yes, go ahead. Maybe it was a question asked in the chat. I'll see that. Okay, no, there is no question. Everybody understood these methods of creating? I showed multiple methods of this creation. You can create these sort of things, and there are a lot more methods there, okay? And we'll keep on learning about more methods, but today we'll do just two fundamental concepts. That is concept of series and of a data frame. Then we saw there are attributes which you can call and to get the data, and then there are different methods, okay? And then there are different operations which you can do, and by that you will manipulate data. And probably in the next session onwards, what we'll do is we won't be much creating these data frame and series ourselves, but what we can do is we'll read the data from the files. We'll have some file which will have data in CSV format or TXT format. So we'll read those files from there, and afterwards what will happen is we'll manipulate data. Okay, we'll manipulate certain data in certain ways. Sometimes we'll filter, we'll have to perform different operations on the data, and we'll see that in the next session. And next session is again going to be a marathon sort of thing, where we'll have at least for a couple of hours, and so that we'll wrap up this pandas data, pandas library, and then we'll go to matplotlib, and we're at least in a good position to learn about the mathematics part. Because my take on mathematics is you should not only learn maths. So you should rather code mathematics and then visualize many of the things. That's why I needed this NumPy, I needed pandas, and I needed matplotlib. And we'll also touch a bit of Seaborn also. Okay. So these four libraries, if you have, you can go with linear algebra with ease as a computer science student, because you need to code a lot of stuff in algebra. Okay. If I was just teaching you the theory, you can just write the theory and give me the answers. But here we'll implement the algorithms and we'll try to visualize every vector and everything. Most of these things we'll have to visualize, because if you see algebra lectures, what we did in that, we had some couple of lectures in which I told you basics, but the visualization part is pending. That is pending because of these. Now we have NumPy background, we have pandas background, and we also will learn about matplotlib and Seaborn. Once we have that, we'll go back to the maths part and we'll learn all the stuff there. Okay. So how many of you are ready for the next session? So here I'll close the recording.